We often look to the stars for cosmic mysteries, searching the vastness above for answers to the questions that have fascinated humanity for millennia. The night sky, with its endless expanse and twinkling lights, has always inspired us to dream big and wonder about our place in the universe. But sometimes the most profound discoveries aren't found in the heavens, but are hidden right beneath our feet, waiting patiently to be uncovered. The ground we walk on every day conceals secrets just as astonishing as those found among the stars. Imagine, for a moment, an ocean not of rolling waves or flowing rivers, but one locked away inside a crystal lattice, deep within the Earth's mantle. This is not water as we know it, liquid and free, but water bound tightly within the very structure of minerals, existing under conditions of immense pressure and heat, far beyond our everyday experience. Scientists have uncovered compelling evidence of a colossal reservoir of water, enough to fill our surface oceans 3 times over, buried hundreds of miles beneath the crust. This discovery was made possible by studying seismic waves and analyzing rare minerals brought up from deep within the planet, revealing a hidden world we never knew existed. This water isn't pooled in vast underground lakes or rivers but is trapped molecule by molecule inside a remarkable blue rock called ringwoodite. Under unimaginable pressure and searing heat, these minerals act as tiny sponges, holding water in a form that's invisible to the naked eye, yet crucial to the planet's inner workings. It resides in what scientists call the mantle's transition zone, a mysterious boundary deep within the planet, sandwiched between the upper and lower mantle. This region, hundreds of kilometers below the surface, is a place of constant change and dynamic processes. This discovery challenges our long-held ideas about where Earth's water originated and how it moves through the planet. It suggests that the water cycle is far more complex and far-reaching than we ever imagined, extending deep into the Earth's interior and connecting surface and subsurface in ways we're only beginning to understand. It even hints that water may have been part of Earth's formation from the very beginning, locked inside the planet as it formed rather than being delivered solely by icy comets or asteroids from space. This idea reshapes our understanding of Earth's history and the origins of life itself. The water you drink, the oceans that cover our world, the rain that nourishes life, all are part of a grand, interconnected planetary system, more intricate and mysterious than we ever knew. Every drop is linked to a cycle that reaches from the clouds above to the deepest layers below. This hidden reservoir forms a vital link between the familiar surface water cycle and the planet's deep interior, forcing us to see Earth not as a static rock, but as a dynamic living system, constantly evolving, interconnected, and full of surprises. Deep within, a watery heart beats, pulsing with the energy of the planet itself, connecting us all to the mysterious depths below, and reminding us that the greatest revelations are sometimes found in the places we least expect. How do you find an ocean nearly 700 kilometers beneath your feet? You listen. Scientists became planetary seismologists, using the Earth itself as a laboratory. They listened to the echoes of earthquakes, seismic waves that ripple through the planet's interior. These waves travel at different speeds through different materials, revealing hidden landscapes. Thousands of seismometers worldwide acted as the planet's ears, recording shock waves from earthquakes. In the mantle's transition zone, seismic waves slowed down, an unmistakable sign of water-rich rock. This subtle delay was the clue. Water, locked within minerals, was changing the wave's speed. Further analysis revealed melting rock only where the waves slowed, confirming the presence of water. The only explanation for this widespread melting at such depth was a vast, hidden reservoir. The echoes from the abyss had spoken. A hidden ocean, not of liquid, but of water bound within the planet itself. The hero of this story is ringwoodite, a mineral you'll never find on the surface. It's not something you'll stumble upon while hiking or digging in your backyard. In fact, ringwoodite is so elusive that most people have never even heard of it, yet it plays a crucial role in the hidden workings of our planet. Ringwoodite forms only under the crushing pressures and scorching temperatures of the mantle's transition zone, which lies hundreds of kilometers beneath our feet. This mysterious region, sandwiched between the upper and lower mantle, is a place where ordinary rocks are transformed into extraordinary minerals. Deep underground, olivine, the most common mineral in the upper mantle, undergoes a dramatic transformation. Its atoms rearrange into a new structure, becoming ringwoodite, which is uniquely capable of trapping water molecules within its crystal lattice. Imagine ringwoodite as a crystalline sponge soaking up hydrogen and oxygen, the essential elements of water, and locking them away inside its structure. This means that water is not just present as a liquid or vapor, but as part of the very fabric of the rock itself. The water inside ringwoodite isn't sloshing around like in a glass. It's chemically bound, integrated into the mineral at the molecular level. This hidden water is invisible to the naked eye, but it's there, locked away for millions of years. Even though each grain of ringwoodite holds just about 1.5% water by weight, the transition zone is so vast that collectively, it could contain as much water as all the oceans on the surface, maybe even more. This makes it a massive, hidden reservoir deep within the Earth. For years, scientists could only theorize about this deep water. Then a breakthrough. A tiny diamond from Brazil was found to contain a microscopic inclusion of ringwoodite, and crucially, it held water. This discovery was the smoking gun, direct physical evidence that water is stored deep inside our planet, far below the surface we know. Ringwoodite acts as a buffer, absorbing water carried down by subducting tectonic plates. It stores this water for ages, slowly releasing it back into the mantle or towards the surface over geological time. This process controls how much water is locked away deep underground versus how much escapes to the surface through volcanic eruptions, shaping the water cycle on a planetary scale. In many ways, ringwoodite is the key to a hidden water world, silently shaping Earth's geology, chemistry, and even the conditions that make life possible on our planet. Imagine a reservoir 3 times larger than all the world's oceans combined. That's the volume of water scientists believe is locked in the mantle's transition zone. This discovery redefines Earth as the true blue planet. It suggests Earth may have been born wet, with water incorporated into its mantle from the start. Over time, mantle convection brings water-bearing minerals closer to the surface. As pressure drops, these rocks release water, fueling volcanoes and replenishing the oceans. The water cycle isn't just about rain and rivers, it's a whole Earth process, with water cycling deep into the mantle and back. This planetary-scale cycle has operated for billions of years, shaping geology and life. The oceans we know may be just the tip of the iceberg. Our planet's water story is far deeper than we ever imagined. To see inside our planet, scientists use seismic tomography, a technique much like a CT scan, but for the entire Earth. This powerful method allows us to peer deep beneath the surface, revealing secrets hidden miles below our feet. When earthquakes occur, they send seismic waves rippling through the planet. Seismometers, sensitive instruments placed all around the globe, carefully record the arrival times of these waves, capturing data from even the most distant tremors. By comparing how quickly these waves reach different locations, scientists can create detailed maps of the Earth's interior. These maps reveal areas where seismic waves speed up or slow down, hinting at changes in temperature, composition, or the presence of fluids. In their quest to uncover the hidden ocean, researchers focused on seismic waves passing through the mantle beneath North America, a region of particular geological interest. They discovered that in certain zones where the waves slowed down, there was an abundance of water-rich ringwoodite, a mineral that can trap water deep within the mantle, and clear evidence of partial melting. This combination was the unmistakable signature of water stored deep inside the planet, far below the surface oceans we know. Seismic tomography now allows us to map not only ancient tectonic plates and hot mantle plumes, but also the hidden distribution of water within the Earth's interior. This technology has transformed our view of the planet, turning it from an opaque mystery into a transparent world where we can observe dynamic processes in real time. With these insights, we can now read the Earth's geological history like never before, understanding the forces that drive earthquakes, volcanoes, and the ever-changing landscape. In essence, seismic tomography lets us listen to the Earth's heartbeat, a rhythmic pulse that tells the story of our planet's inner life. Each tremor, each subtle vibration, reveals a little more about the world beneath our feet, helping us unlock the mysteries of the deep Earth. The mantle's transition zone is a thick, mysterious boundary between the upper and lower mantle, 410 to 660 kilometers deep. Here, immense pressure transforms minerals. Olivine becomes wadsleyite, then ringwoodite, which can trap water. Tectonic plates carry ocean water deep into this zone where ringwoodite soaks it up. The transition zone isn't just a passive layer, it's an active reservoir, trapping water for millions of years. When heated by upwelling plumes, ringwoodite melts and releases its stored water. This water can rise with mantle material, eventually fueling volcanoes at the surface. The transition zone is the crucial link, connecting surface oceans with the hidden ocean deep inside. It's the planet's circulatory system, moving water between worlds. This discovery forces us to rewrite the story of water on Earth. Instead of a dry planet that got its water from comets, Earth may have been water-rich from the start. Water in the mantle changes everything. It softens rock, drives plate tectonics, and makes our geology unique. The deep water cycle is linked to volcanism and earthquakes, influencing where and why they occur. Understanding this hidden reservoir helps us model geological hazards and the evolution of our planet. The water in our oceans, atmosphere, and rocks are all part of one immense interconnected system. This system has shaped our climate and continents for billions of years. We live on a world with a hidden, watery heart. Only now are we beginning to understand its rhythm. Every discovery opens new questions, and Earth's hidden ocean is no exception. The next challenge is to map this reservoir in 3 dimensions. Are there wet and dry patches deep within? Scientists will use seismic tomography to trace the history of water delivered by ancient subducted plates. This could reveal how the deep water cycle has evolved and influenced Earth's climate and geology. The implications reach beyond Earth. A rocky exoplanet could have a hidden ocean, even if its surface looks dry. Internal water could drive volcanism and create atmospheres, making more worlds potentially habitable. We must broaden our definition of a water world. Life may exist on planets with hidden oceans. The quest to understand our own planet's interior is now linked to the search for life in the cosmos. Our journey inward is also a journey outward, into the universe. Earth's hidden ocean reminds us how much we still have to learn about our home. We've explored space, but the world beneath our feet remains a frontier. This discovery inspires new questions. How will the deep water cycle change as Earth cools? Could our oceans one day drain back into the mantle? Each answer reveals a more intricate picture of our universe. A tiny diamond from Brazil held the key to a planet-sized secret, showing the interconnectedness of all things. We are explorers on a planet we're still mapping, driven by curiosity and wonder. The most exciting part? There are still more secrets to uncover, both in the stars and deep within our remarkable planet.